wanted to
at
show
least
things
we
what I
can
have
discuss.
tried today. So
And see, instead of
don't
like
know
working
because
out
it was very
individually, right? My point is, instead of working out
uh,
individually and waiting for 2 days and coming out, let's work like this. Whatever thing, because we are not clear with the basic things, right? So whatever
uh,
activities are, I have some suggestions. Aman has some. You have something. Let us implement and conclude now itself at least one small point also, so that at least we can say this small point we have
mm,
completed, because from past 2 minutes there is no much conclusions are coming out. We are highlighting
Yes.
where we have
mm.
stuck up, and we are working out again, we are at the same place. So instead of reviewing, we will
Okay,
review
okay, okay.
fastly, but we will try to like
Uh,
change the code,
uh.
how the implementation is, whether anything it is like working out, we'll try to do in that way.
Yeah, so that is where, look, I'm just now becoming a layman. I don't know what exactly. So database, I've taken the data, right?
Mm.
And then with the hist, I have shown you like this is the normal distribution how it is coming up.
Mm.
So it is not looking like a bell curve, right,
Mm.
Aman? The what
Yes,
expectation
yes.
we
It's
have with the
not.
data,
It's not.
it's not. So this is one point where what exactly we are driving from it. If it is not having normal distribution, then what point it is coming up
Then basically our
generally?
data is not stationary. I think it's coming out that only.
Yeah, yeah. So now this is one part which is saying data is not stationary. But the moment we used to drive that Decker-Fuller thing, like through mean variance, whatever we have tried, we are seeing data is distributed fine. It is not having much variance. You can see here, right?
But variance is fluctuating.
Variance is fluctuating actually. Yeah, mean is almost same. Mean is not
Yeah.
moving
Means
fast.
graph is not completely out of that bell shape, right? It has some bell shape, so we can expect some that what is stationarity. We
So
cannot
that
say
is
hundred
where
percent
I
both the
was
way.
telling you. No, this yeah. So this local minima part is like looking bad here. That is what I don't know. It's a big drop. How this is going to play things here, we don't know about that. But ideally, a graph should rise like this and
Correct.
slowly go down. No, then it is going to be good one. But it is
Mean
dropping
is constant,
very
but
straight
variance
away.
is
It is dropping,
fluctuating.
fluctuating. Yeah.
The mean is
So
starting from
this is
zero,
one
but
point we
variance.
yeah, yeah. So it is starting from zero and ending on zero itself, but in between variance is fluctuating.
Fluctuating.
So that is where we can see in the calculation also. Then this part is clear to everyone. Like when we are going with this fuller test, everything is coming and it's saying like as per this p-value, this is not having any like this is rejecting the null hypothesis. That is, it is stationarity is there.
Sripati,
That is what it is coming up.
Sripati, your mic is making
Huh?
some disturbance. It
Hello?
is rubbing somewhere, or your mouth is very nearby, something like that.
Is it now? It is fine.
Yeah, it's good.
Yeah.
Now little bit again coming.
Yeah, yeah. Okay, okay. It's still coming.
It is okay. Means now it's okay. I
Okay,
will tell
okay.
if it
So
repeats.
that is what I'm telling.
Yeah.
Yeah, yeah, yeah. So, so that is what now this part is making what conclusion like from the visualization we are not able to make out what exactly it is having, but when we are going with this fuller test, it is confirming the data is stationary, right?
Yeah. And still, we have not
So
figured it
that is
out
where
why
the
it is showing stationary.
correct. So that is where the conflict happening. Like when we are going with visualization way and when we are trying with fuller, and then I tried to do some mean and rolling standards like this kind of comparison through visualization. Here also, ideally what I have like could be I'm making wrong statement, but I heard like data should be if it is going to be nearby to the mean, the green one, then it is good, and if it is not near to mean, then it is like bad. So like lag one, order one is not showing the good response. But when we see this one with lag one and order two, the things are looking like mean is not fluctuating much and it is going that way. So I didn't understand what exactly this particular things
Oh,
are
what is
doing.
that order?
If somebody has tried
Lag I understood. What is that order?
Order is
where
difference order. How many times he's differencing it?
Okay,
Like he's
okay.
differencing it
So
two
it
times.
is
this one,
like
no?
a graph of a final implementation model.
Yeah,
Okay,
he's plotting that
okay.
only.
Uh-huh. So
He's
suppose
applied difference to convert it into.
so
Actually, there is a difference for function.
Yeah, yeah.
okay difference function.
So what we are trying,
No, giving both how you made it a trend. That's what I'm seeing.
what giving both?
Like a lag as well as a trend you have means a remote model you have applied and you are getting the trend or before that like you have
No, no,
run a
there is no
code.
arima.
Ah,
He's transforming it
There is
into
no,
stationary, sir. He's applying difference transforming
no,
okay.
no, no, that is what I am not
and making it
applying any
into
model
series.
here.
So the difference I can see here, but where the lag you are defining? Interval in between lag series. So after differentiation, you have applied
Interval,
lag,
I
right?
think he's applying.
Yes, 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 that is what.
Okay. The final graph you are making it.
Yes, yes, yes.
Okay.
So I am plotting lag, actually lag
Okay.
one
Got it.
plotting,
Got it.
then lag three, then lag one order two. Got the point, no?
Mm-mm.
So they are also like not able to reach out to a conclusion like what exactly we can bring out the
No,
detail
no.
in here.
Here another thing which I didn't understand is what is your expectations of the graph?
So the expectation, what I read in the article where from I tried this,
Mm-hmm.
when they are running any mean
Mm.
and the original value, so they are saying the original value should be always remaining closer to the mean, then it is going to be a good data.
The graph,
That is
you
what
mean to say?
I was going. Yeah, in the graph. Yeah, correct. So this
Oh,
part just for like if somebody is interested can go through. I have to
okay,
explore it
okay.
again, deep level. But yeah, when I started doing this lag plotting individually
So
for entire
here
AQI
where is the
data,
mean? Here where is the mean and where you are referring? The graph I want to understand more. Rolling mean is
so we
Yes, yes.
have
green.
I want to also see that.
green one is the rolling mean, rolling standard deviation is the black one, and the lag one order two is it is like
Black one.
showing up lag one order two the red one.
So after so okay you have some data set of that rolling mean and standard deviation normally we will calculate that it is coming up and lag one order two how you are getting that data.
The lag one order two you can see here. Lag one order two is by plotting layout. Yeah, lag one order two series. So this is what the formula been applied. So we have a function defined difference. In that data set is data.aqi interval is one and order is two. So this function is playing role here. I told you, running one function we can check multiple. We will give the interval and order based on that we will get. If you want lag 2 order 3 c something like that, so this is going to work out. So what the logic here is interval 1 order 1 for you in the range order, the difference is less for I in the range of interval length of the data set it is taking. Okay,
Still see I can see the difference return is difference right there, correct?
this one na.
No, in the function what it is returning it is
Ha, ha.
returning the difference right.
Difference, yeah.
Correct.
Correct.
So
It's appending all the value, yeah.
so we will apply some transformations, that is the difference thing, to make it stationary, that is also clear. Okay, so after that you are from that data set you are running or you are calculating mean and standard deviation to check whether still the
Hmm.
stationarity is
Hmm.
there or not. Okay, that is also clear.
Here you
And
can see, like,
uh,
I'm not calculating mean. I'm trying to plot the mean. Like, it
that
is
is
not
what
going to show any value for mean, but it is
it will
correct.
calculate, and then
So it
only
will
it will
plot the
try
mean
to
and
plot.
STD. Correct. Internally, it will calculate and plot it.
Correct.
Yeah.
So here mean and standard deviation I am clear. Same way how the internal not that lag part where it is, like here you can see clearly mean and standard deviation, right? So like that, where is that lag
Hmm.
part? Because I can see a trend means there should
Look.
be some values.
Just a minute. So this last is difference series with lag 1 and order 2, right? So this
No,
is
no.
lag
Go
1
go go.
order 2
Wait.
dot set type.
Hold on. So here
Uh, uh,
you can see label is equal to lag 1. Oh, it is only label, and directly you are making series of lag 1 series. And what is the lag 1 series again? So it is not a lag, it is actual series, actual this one, right? How you can say that is lag
which one you're
1
telling?
lag 2? It is like see what it is. We have some data
Yeah, I
set.
am also not able to understand.
So we have some data set. Over that you have made a difference. Okay, after that you are taking mean and average. So whatever the original thing na, it
Correct.
is been plotted as a lag, but lag 1 2 3 everything it is same. Whatever difference it is, you are just naming it as a lag 1 2 3. What I thought is that lag means all it is in the background, there is some calculation for calculating lag, right? So it is happening like that and it is plotting like that. I thought it
Hmm.
is the original series of data,
Hmm.
order number, not the interval number. So interval number, anywhere you have changed interval 1 to 2? No, right?
Interval 1, I think everywhere it is 1. Lag 3 series, it is having interval 3. Lag 1 series is having interval 1. But interval 2, I have not tried.
Okay, 3 also it is okay. My question is like order
Hmm.
1 is means it is
Hmm.
making only one difference, right? Order 1 means one
Correct.
difference, and interval
And
3
then,
means here interval 3
uh,
means what it is, means every third interval it is differencing. Here only these two parameters only I got like confused. For me, differencing order number, how much you will give, that much back it will go, and it will try to difference. That is clear. And what this interval says,
okay, so that is where like interval equal to 1. So even now I am getting confused here because I was going through the article and then according to that I have taken this code. Let me revisit again and then interval, I think it is taking 1 by 1
no, interval is the
because we have
Yes,
actual the
hi
changed,
difference.
Shripati.
because it is going
Hi
to be
Ishwar.
hour.
There,
That is what.
Yeah, okay, go ahead, Ravi. Go ahead, Ravi.
yeah. By default, the values given in this difference function is interval equal to 1. By default, if we are not giving any interval, it will choose that interval 1. But here you can see in lag 3 series. Here, Shripati is passing interval
Interval is
equal to
3.
3. So in this, yeah.
Correct.
So it will pass in difference function interval equal to 3, and I am also thinking interval equal to 3 means it will take 3 periods at a time,
That is what like
like first hour,
first
second hour,
period.
third hour.
Yeah. Correct. So it is representing hour. That is what I was
So
estimating that
that
time.
we will say order, right? Now difference, when we are making difference, don't
No,
see this function. Don't
order
see this function.
order
When
is different.
tell what is the order then?
Order means it is a like we will take square root and cube root, right? This is a x square, x cube, x power 4. This is order. X power 4. Here 4 is the order. This is order equal to 1 means simple x
So
in
where,
mathematics.
wait, in that
Right?
function, u order is going to u, right? So where u is applying? Is there anywhere it is applying u? No, right? Just try to see. So how many
Yeah, there
orders?
is
No, no,
no u.
it is
So
For
if I
one
if
time only it will run. Order is 1, right? Order
uh,
is 1. So that for loop will run only one time. If order is 2, then it will run 2 times. That
what
is
what is the
valid,
meaning in
right?
running two
it
times?
is
Here
for
in
running.
What is the meaning in running two times? Same output will come, right? Any change in output will come.
no, I 2 times it will return as you said.
Yeah, suppose the data set will get repeat because the difference happened, it is going to happen, right? So the difference, if it is say like it is some 5, the first two values difference is 5, then it will create
Yeah, see,
5
one
6
second, Ishwar, I got the point. Here in third step you can see lag order to series. Okay, there he is creating a panda series. So once you runs this function difference function, then it will, as you said, it will return two values. When if you uh, go with the first or second one, it will return only one value. Like it will repeat only one time, right? How many values you will, if you get in one time running that for loop, if you get 500 values, it will take add into that series 500. Whereas in this it will give 1000 values double the times.
so
And I
but
don't know
repeated,
where
right?
it will
Those,
take.
so first 500 and second 500
Yeah,
are repeated, right?
repeated. But yeah, now they first two will have 500 500. In third one we will have 1000. I
Correct.
don't know for which use case they are
uh,
doing this.
I also have the same thing. That is what Sripati. Like order 2, if it is making na, it is running for 2 times, and whatever first time it is running na, same values it is like copy pasting in the second time. Okay. So why we have to repeat that and appending that, I am not sure. But this function says that one. So I got confused. But normally whatever differentiation we are giving, if you name it as a order, not apart from this function, that order is like one means one time difference, two means two times back, go back two values and make that difference, like that. And interval
No,
it is
while doing this, I took interval as hour, like on hourly basis. Every hour it is
correct.
going to do things.
but
And that
but
is what I
general
consider.
terminology, this function I am not talking about. General terminology, even Aman is said initially,
In
right?
general, you are telling, yeah.
So whenever we are saying order, that order is how many times back we have to go and minus it, the difference order. So it is first order difference means go
Hmm.
back one value and difference. Second order difference means go back two values and make difference. So that order terminology we are making there, and interval where we are making is wherever making like correlation, right? So how much lag and interval it is directly like correlated. So how much back we have to go, how much interval we have to go back to make that relation, autocorrelation. That is interval. So this terminology, it is like they have defined like that, and we are using it. That is different thing. But okay, I got some understanding. So whatever curve it is, their base curve, over that they are running average and mean and then standard deviation. Okay, Aman,
Right.
Aman, correct, right?
Yes, yes,
Hmm.
yes.
Yeah, okay. So this, from this again we can say like mean and standard deviation only we are going to observe. So this needs to be like a constant.
Constant, yeah. It should be
Con
like
Closer to mean, both are same. Means you mean to say it should be closer to mean, since mean is constant. So it is like
uh,
it has to be like a constant. Both are
so
same way.
that is where like I kept it apart. I just went to this part where I started checking the linearity of our AQI. these things like showing up, that autocorrelation is not happening in between the data. So if you will take 24 hours data, the linearity is still there, but you can see like it is not showing the best fit, like kind of thing. Outliers are there in that very case.
Yes,
When we are going with 1 year data, you can see like how it is appearing.
Even Aman, sorry, my view is also like the same thing, because autocorrelation, whenever we are trying, it is not at all giving any like relation at all. It is going like top. Okay, that curves, that lines, Aman, we have seen, right? So the lines are at top
Yes, yes.
because there is a very less correlation. That may be one possibility. And second possibility which I have read is, right, if the lines are that much straight above the confidence intervals, then it says that the data is not stationary. So you have to make a stationary and then come back here. Then the curves, na, it will come inside that interval, confidence interval. So
You can see
see.
this is for 3 months data. For 3 months data, when tried with the autocorrelation that plotting, you can see like how the lag plot is coming.
So your conclusion, now my view, I am telling overall up to here what we have gone through, that Ed Fuller method is only like misleading us. Okay, it is saying stationary, and we are following because it is showing some value of it. And whenever we are seeing trends, it is nowhere it is like constant mean, or it is not there. Correct. So we have to like choose, both are like opposite things, right? So we have to choose at least one. Based on that, we have to move forward. If you ask me, I will not go with that fuller method, even though there are a lot of statistics behind it, because I can see the graphs. It is like seasonality I can see, and as well as the stationarity I cannot see at all, even after applying difference or transformations. But this, how you get it, I didn't. On which data you got this one?
So this has
Autocorrelation.
been done resampling on monthly basis.
Okay, that is what you told, right? So monthly basis, again you resample.
Hmm.
That's why it is coming. But hours is like a hourly basis.
Hmm.
So then the accuracy may decrease if you are going to that level month. So the accuracy may decrease.
So after,
Even
so
last
what,
bit,
like we have to give 1 hour.
1 hour we have to give, because see 1 hour, our
So
uh, our model, what we want is, we want to predict at 1 hour level or 1 year level, that we have to decide, right? So our best approach is getting 1 hour, if not possible 1 day. Okay, so
hmm.
1 hour if you think, then you have to take
Okay.
1 hour data. Then based on that, it will try to like get accuracy up to that level, because you have a lot of huge data at 1 hour. So it will try to match to that one. If you take like a monthly data, then to the monthly data it will get nearby, right, model, not hourly, because
Hmm.
it will take the mean of it, and it will try to figure take the advantages. Even this auto correlation, this
And
is
the
what I am
final
telling.
plot is this.
Mm-mm. Even this is what I am
Yeah.
telling
So
now,
that is
that
where
there is
I'm
one.
saying, if you will go with decay Fuller, it is saying we reject null hypothesis. The first statement is coming from decay Fuller, that you can see.
Mm.
Then after going through decay Fuller, autocorrelation is saying no. The way it is appearing, nowhere it is looking at stationary data. So
So
that is where like I am totally confused, like what kind of data we are dealing in. Even I got stuck completely now.
so Aman, what do you say? What do you say? Whether we will believe like at Fuller method, or will like keep
In one
graphs as
screen, I'm
At
trying to show conflicts, like both the conflicts are coming in one screen, you can see.
at
yeah.
last we have to build model, and we have to see the autocorrelation graph. So how can we trust decay Fuller test, because it's showing is stationarity, but the data is actually not stationary.
So what are the points are there which has proven like no data is not stationary? The
This
autocorrelation graph,
autocorrelation graph itself.
See,
correct? And
except that at Fuller method, that one, right, result, everything is showing like it is not stationary.
it's
Not
against,
stationary.
it's against.
Even graph one also.
Hmm. So
that is
we
where,
will
yeah.
keep that at Fuller method aside, okay, for time being. Maybe we'll after getting some conclusions out of visualization, then we will see whether we will consider that or not. Okay, so our point is we are missing something in graphs, visualizing the stationarity. We'll try to achieve that, okay, somehow, and after that we will come back to that at Fuller test. We'll consider that.
Yeah, I also think in that way only
So in
it will work.
this getting stationarity in visualization, what we can do? First thing is like the bell-shaped curve. Okay. So whether Sripati, we will start doing it instead of just discussing and making some conclusions out of it, and again coming back after 2 days, right? We will try small
Mm,
things here, and
mm.
let it see the how it is coming, and make some conclusions for those small things. If you want, even share with Aman. He is good in coding, so he can make it fast if you want.
Code I have uploaded on that Git today.
So Aman, is it okay whether we will like make that graph bell shaped? After that, whether we will rerun so that at least some improvement. After that, we will try to differentiate the thing,
So
first order,
what it has
second
been
order.
said with this lag graph also, linearity. Look, we can see outliers are there with this graph, but at least we can see the linearity, right?
Yeah, linearity is there means correlation is there.
Yeah, that is what linearity means. Like there is some y equal to mx plus c is there, no? So keeping c constant, like whatever the dependency, like it is here yt and yt plus one. That is what the graph is happening in between. So this will continue even though your data is like stationary, no? This linearity will continue with 1 day data or 24 hours data, 1 year data, and then the 6 months data. Lastly, like this is how 6 months data. Yeah, correct. So it should not be haphazard way. Like it got reduced. With 1 year data, you can see the linearity gone. It means there is lots of fluctuation. So data should be looking as if that linear property should be maintained, and at the same time,
No,
the assumption what we are making.
Sripati, that statement I want to
Hmm.
like make it some correction. Okay, linearity should not be there. If you want to achieve stationary, then that
Hmm.
linear relation should go up, because there is some relation between two things, right? If you apply differentiation, then that linearity it will go like stationary over the period. It will go like stationary. That
So
is
you
that
mean
is
to
what
say this linearity should not be appearing?
we have to remove that, and we have to make correlation. See,
Oh, then
differentiation why we are doing. See, if it, the variable is completely dependent on that back it by multiplicative or additive, then we want to remove that. We will do that decomposition, additive or multiplicative, right? If it is like additive, so if the back value t minus 1 is varying, then t is also varying by this much additive times. Okay, suppose 2 times means if some value in t minus 1 is increased by 2 times, means the t also will increase by same amount. So we want to remove that thing and make it stationary. That is what additive and multiplicative says, as per my understanding. That we will remove, and after that we will check these parameters.
I have to revisit this part as well. Like when I was going through there, it was telling something about the linearity of the property. Okay, fine, no problem. We'll keep it apart.
Can you repeat that? Means what it says exactly? Maybe I can also correct
Like
it if I am wrong.
because when I was going through the article, no, for checking all this through visualization,
Mm.
so there they are trying to say like data should not be losing linearity because it is a autocorrelation thing. This lag plot, whatever it is happening, it is an autocorrelation between its own data. It is not with any other data. Like we are having single level time series like univariate thing, right?
Mm.
So what it is trying to establish relation with its own data, how it is changing with time. That is what it's trying to establish with this plotting. So I have to see like what exactly then it is having a meaning in terms of stationarity.
So
Give me some time on this then.
okay, one question. Suppose the trend is like rising, okay, like linear. Okay, the first point is consider the same trend. The points, it is not like t and t plus one. Let us say time and then the value. If the trend is increasing like that, okay, then what will be the relation between t and t minus one? It is also linear, right?
What is the last part?
See, suppose the same trend you have taken t and t plus
Hmm.
1. Don't take those
Hmm.
things. Consider time with respect to the value.
Hmm.
Okay, so it is
Ah,
also saying that it is linear, means that the trend is going up. Okay, suppose think that the trend is going up with some ups and downs, but if you see
uh-huh.
it is, if you smoothen, it says some linear like this, what we have done. Okay,
Mm-hmm.
seeing that, what will be the relation between t and t plus 1? Is it a constant or is it a linear again? Suppose take 2,
Now,
4, 6, 10. Take a 2 table. Okay, 2, 4, 6, 8, 10. So if you see, it is a linear graph, right?
hmm.
So if it is a linear graph, then what will be the relation between 2 and 4? It will be like additive or multiplicative, both. Okay, mostly additive, you can say
Okay.
plus 2 plus 2 plus it is adding. So it is like
Hmm.
additive relation it is having. So what will be the relation between t and t plus 1? Suppose 2 and 4. It is linear only, right? Or
Hmm.
constant, t and t plus 1. Suppose 2 and 4, it is like the relation is plus 2, and 4 and 6, it is like uh, 2 again, so it is constant. If the
Right.
graph is linear, then the relation between t and t plus 1 is a constant.
Hmm.
Did you got the point? Take the graph 2, 4,
No.
6, 8, 10. Okay,
Hmm.
that is the two table. Take, consider that we have data points 2, 4, 6, 8, 10. Okay, now if you take the relation between t and t plus 1, that means 2 and 4. What is the relation between 2 and 4? It is plus 2, right?
Let's go right.
Same 4 and 6. What is the relation? Plus 2, correct?
Okay.
So
Hmm.
the relation between t and t plus 1, there it says 2, 2, 2, 2, 2 everywhere, right? Along
Got it.
the
It's like
t and t
uh,
plus 1, throughout the line, it is like a constant relation between the t and t plus 1 over the series. It is 2 only.
so you
2,
mean to say it's a constant thing, right?
correct. So if the trend is like our graph, initial graph is like a
Hmm.
linear graph, then
Hmm.
the relation between t and t plus 1 should be constant. It will come as a constant. That is what we have to see. Now you are saying t and t plus 1 is a linear, should be linear. It should not be linear, it should be constant. If the
Okay.
original trend is linear, means
Hmm.
like 45 degrees, then our relation between t and t plus 1 will be like uh, constant. Difference between t and t plus 1, 2 and 4, 4 and 6, it is always 2. It is constant.
No, fine. So that is this part again. I will try to see like what exactly the concept it was talking about. So, so this is another thing. But meanwhile, like overall, the situation is not in support of this stationarity. That is what data is not stationary. So what next can be thought on this? That is where the question is now.
I see that is what things are not going well. Okay, so instead of
Mm.
uh, doing somewhere and coming up like that, how much we can do now itself. Make it if do you have some suggestion, like make it like a bell shape curve, normalize that data, then normalize it. Then you want to do some other thing among our three, just take up some suggestion between our three. We three will come into some understanding. Okay, this is how it is being done. We have done these observations and it is happening, it is not happening, and after that we will make some conclusions. Because for this meeting, to be frank, I can say I don't have any points to present, because I gone through so many articles and every article says the same thing, but I didn't get any conclusion out of it.
I
No,
have also
even
tried only go on to dozens of articles, but not lead to conclusion whether it is reaching
So
a
that's why what
stationary or
what
not.
my suggestion is, let us attack as a V3. Like if Aman is okay, then he will share his screen, and we V3 na will say, okay, we'll do this activity first, second activity we will do now itself, and let it go. How much we can do today, leave it. Then after that, tomorrow morning or in the evening we will work it out. Then like at least combinedly we will work for some time and individually we will work for some time, because individually working throughout the time it is not working out, it's not making any output. Is it okay, Aman? Now shall we
Yeah, I'm
like try
fine.
something live? If you say okay, then means he will transfer a host to you.
Yeah, meeting is going to over.
Yeah, we will reshape, we will reinitiate now.
Yeah.
Okay, then we will try to like Sripati, we'll try to like whatever suggestions we have, or I have, or Aman have, we'll try to implement now itself. Let's see, because every code we have, everything we have. Only thing is we have to say change this parameter to this and check it. Like that, if you make something and also you have some code which can auto generate the trends. Okay, so we have to make at least code like that, make some changes and see the output, stationary or not, relation between things t and t plus 1, those things at least we will align, and try to alter, play with those things, parameters which we have confusion, and see the output how it goes.
okay.
Okay, let's rejoin then. I think it is going to finish. I will end now and I will share that code again. Ravi, please rejoin.
Yeah, yeah.
So Aman, I will do one thing. I will take some 5 minutes. Okay. So whatever I
Okay.
have, some visions, right? I will try to share and I will finish it and I will transfer to you. Okay.
Okay. Okay.
So yeah, today I have shared one article in the group. Okay, so what it says is, it says like there is a model which is like a STL. Okay, so it is like in build stage and we cannot import directly like with inbuilt thing. with stat model, so we have to do this kind of code. Okay, so after that we can able to import. So what is the importance of that? I will try to share with you. See, normal trend, seasonality means what we know like the curve, it will repeat like the same pattern, right?
Yes.
So
Yes.
what this model says is, even that pattern, if it is like increasing, now you can see it is the same shape, it is like smaller in size, and if you go on the thing, it is like larger in size. Even such kind of incremental exponential seasonalities also it will try to capture. Okay, so that is what they are trying to implement in this. So I tried that one, but nothing worked out in good shape. So what I have done is, I taken the one code last time and I try to do the same thing. Histogram, this one, this is again, I have last time also I have discussed, this is the mean standard deviation of the original graph. And when I have taken this 1 year average, I can see this is a straight line. Since I can see January to January, it is having seasonality, so I think that okay, the seasonality period is 1 year and I have given that rolling window as 1 year, then it is showing some a straight line. But another thing, if you give like such a big average, then definitely it will give straight line. It may be wrong, but since the seasonal period, what I have seen is other videos, they are doing like whatever seasonal period, they are giving that as a window size. Since our seasonal period is 1 year, I have given, but 1 year it is, since it is a big data, I can see it is a straight line. It may be wrong also, but that is observation. And again, this is from Maman code only, this is also from Maman code. Then coming back, this type of trend, that seasonal decompose, even he has tried, who, um, Shubham. Okay, this is what even I like to, like what it will do. This is the original trend, and this is original graph, I can say. This is the trend out of it. What is the shape of the trend? For this, from this it will decompose into three parts. It will split this same trend into three parts. One trend, and what is the seasonality? See, you can see from here to here, this is one curve. Here to here, one curve. This is the seasonality, and whatever left out from trend and this one is like the residuals. So these
Residuals, yes.
residuals, so this I try to like apply some transformation and try to see these things. Okay, then what is my observation is, still this seasonality is repeating by somehow. So that this is a simple thing which is done for myself, my purpose. Okay, so what it is like, one article I have seen, like you take these upper limits and lower limits. If the mean curve is traveling in between, and the gap is like, it is not going like a V shape, a cone shape, then it is like additive. If whatever space here it is and here it is, if it is same, then it is like a additive kind of relation. And if it is going like the gap, here is a smaller gap, and here if it is larger gap, like here you can say here smaller and here larger, this is like multiplicative relationship it is having, like that. So I have drawn and I try to understand, but similarly it is like mixed kind of thing. It is not, we can say simply like it is additive or relation or multiplicative relation. And another thing, Aman, for you, so this thing na, since if the seasonality is 1 hour, the cow na, it is trying to overlap the thing, and it is coming as a blue, so which you have shared also. So that if you are giving that window size as maximum, then we can see this one. So there is seasonality at every hour, it is present, it is there. So after that, what I have done, mm, here it is. So I try to initially do apply this STL. Okay, so I have taken this data and I have given robust is equal to true, so that even the curve, if it is increasing also, it will try to exponential also, it will try to capture. And there is a limit like seasonality, odd number we have to give, and minimum 3 period we have to give. since it is odd and minimum we want, I have given 3 and I tried to fit it and I plotted it. Then the seasonality curve, it is defined here. Okay, somehow it is repeating the same 4 trends double time. So after that, what I have taken, so we have the data, seasonal data, and we have original data. So I subtracted, I make it difference because we want to remove seasonality. Even that this also it shows the same thing. So we have to remove seasonal thing from the original thing. Then the seasonal data will go off. Whatever actual relation, auto correlation data, it will be remained, and we can predict that thing. So I approached that method. So from original data, seasonal data I have removed. So I have that data set. Over that, I have applied again that same method, that graphs. Okay. Then also I can see there are a lot of seasonal things I can see here. So it is removing or it is not removing. I didn't get the idea, because if there is some difference, right, definitely the seasonality should have effect, but I can see the still seasonality it is present. So I got stuck up there. That is what my observation. And this is auto correlation. You this how many lakhs we are giving here, that many lakhs it tried to show. I wrongly given this is as 1 year. I took lot of time and I tried to predict this one. So this is good, like this point to this point, the auto correlation between our points, it is moving like this. So it's coming down and it is going negative or going up. This is what our curve says. That is what my observation. I struck up there. Like even if we are removing the seasonality, but still the curves are the seasonality remains the same. So what else we can do, or how we can confirm the data is getting the seasonality is getting removed? So maybe we
I'm
can.
also stuck up here only. I have tried differencing also, transformation also, but the curve is not.
So
It is stable only.
Uh, so here, taking normalization of data is nowhere concerned, right? In this approach, since we are not touching the statistical values, it is only visualizing
Yeah.
and removing. So I cannot see any we have to compulsory make normalize the data and then do this activity. I cannot see this, right? Is it right statement?
Yeah, I have not seen in time series that the values are normalized and then
Uh,
applied. Here we check for stationarity, then
Only
what is
point
the
is,
need
if
of
you want to apply any a Fuller method or something like that, to get that accurate results, we have to make that normalize. That point I agree, but visualizing, no need to make that as a stationary.
yeah.
So Sripati, that is what my thing. So what we can do, okay, that especially removing seasonality, what we can do, you even Ravi, we will see now. We will try to like keep one point and we'll run that one. We'll see how things are moving. At least we will come to know some new things. Okay, if this way we are applying this kind of graphs we are getting like that, at least we can. Observe and we can live at least for today. If some output if we are getting, that is well and good then.
So that is what, like, we have to find. So what are the things we have tried to make it stationary?
Think, okay, make it like level 0. Okay, we are at level 0.
Hmm. Hmm.
Everyone tell their views what we have to do. Now we will do it and we will observe it. If it is not happening, then we will try to do another thing. We will observe it. Okay, and to make this exercise simple now, whatever this automatically that all type of trends it is coming, uh,
Hmm.
you try to suggest Aman. He will copy paste that code
Yeah.
and he will try to visualize it, so that we will change some parameters and see all the required trends. Okay, what was happening, required stationarity is coming or not, what is the relation between one and the other, like t and t plus 1, this graph one thing like that. So Sripati, what are the things we have to visualize? Like this trend, I feel like it is like handy. We have to definitely we have to go with that. And in your trends, na, even some trends are good. Like so, which one you prefer? Like T and T plus one, it is good. Like we have to see that relation after changing, how the relation is going to happen. That I suggest to
Yes.
Aman to make it. Apart from that,
Uh,
just go through your code wherever you visualization you feel like we will observe after every like transformation. He will
mhm.
put it that here. So then at least
So
code
he,
wise we will standardize and we'll try to play
uh,
with only variables parameters.
okay. So right now, any transformation like somebody is doing or what?
No,
Aman
no,
is doing.
I'm expecting from you now.
Hmm.
Uh, just standardize the code. So in your code, there are like T and T plus one graph is there, right?
Hmm.
So try to share that code to him. He will paste it there in his
No,
code.
code I've already given on Git, so it can be copied from there.
Yeah, okay.
Go to
Then
Git.
Aman, can we like implement that one? T and T plus one.
Yeah, we can.
You can go to the Git and whatever the code I've tried today, no, everything is there. Last one, 1 hour.
Yes. So
So we'll try to go through only visualization in this. Whichever we Aman you feel na, just try to implement in your sheet so that we'll try to change the parameters and see those visualization how it was changing. Don't see the code, see the visualization. If you like that visualization, then copy that code. So do you feel like this is required? This is a normal thing, right? Like how
we
the
have
mean
done
and
it.
variation. Ah, we have
So
done. We have
I
done. Not
think this has been done, right,
yes,
Aman?
yeah,
correct.
yes.
Only thing is it is taking one, two,
Try with
three,
the below
everything in
code.
one place. In our case,
Hmm.
we have individually we have to give like one, two,
Ah,
and
yeah. Uh,
but it is okay. We will go one by one only. We will not generate everything in one shot because that is big code. So we have to maybe change. What because here that lag whatever here it is giving we have to change that 1 2 3 times we have to just make a run of it.
Okay.
Come down, don't close, come down. The TNT plus one, this one I feel like we should keep how much like lag we are giving, so that much lag the relation wise how it is moving we will try to see that also after applying transformation.
Transformation. I applied transformation also.
Means we will try to change that parameters, right? So after each change in those parameters how this trend and below trends are changing we'll try to see it. Okay, so now is it working fine? Try to generate. If the graph is coming properly as we expected then we will try to change. Okay,
hmm.
so whatever visualization, any other visualization do you think Aman or Sri or Ravi to see that our uh, data is stationary and relation wise, correlation wise, these two.
Can you
Decomposition one
repeat
we have
again?
done.
Ishwar, can you
Wha-
repeat again?
Visualization wise, see what activity we are going to
Mm.
do now is we have code, okay, full set of code, okay, and we want to change some parameters like lag value or a difference value, and we want to see how our data is changing. Okay, is it coming stationary or it is going out of it, like we want to change it. So for that how we want to go is only with visualization, not with statistical methods, because we think that statistical methods are misleading us. So visualization wise, these two charts we have added. Apart from that, to visualize that it is a stationary or not, or it is having some correlation with the data or not, which type of correlation means which how much back the correlation is. So you have any other thought apart from these two visualizations?
We have not tried this time series box and whisker plot, right, Aman?
No, box plot we have not tried.
So what it says box plot time series?
Box plot helps us to detect the outliers.
There is a, for yeah, outliers, okay, but here, but same thing. We want to find out outliers.
No, but it is invariant, so I
Before
have not
outliers, we
seen
have
any.
to be clear on the stationarity part. That is what like.
Then, if you are saying that one, then normality also coming into picture, right? If you want to remove
Yeah,
this outlier, then what we have to do? We have to do only this normalization. But
Because
how?
apart from like we have tried almost all the aspects,
Wait,
few
wait.
like keeping here and there.
Go that linear relation, Aman. So linear relation, this one. So see among that total data, now outliers are very less. I feel like it is not like huge. It is
yeah,
not
I
well
also.
distributed. It's okay. Means we can attack in the later stage also. It will be fine only. Because see, most of the data it is having in line with the data. Only few are going out of it.
Yeah.
Okay, so any other thing? What from normalization?
Yeah.
Autocorrelation we have tried, na?
Yeah.
So there is a first. So a correlation is this linear graph, and second graph is that seasonality. Okay, so how we will decide now? The second question visualization. Let us keep this one. Once anything we thought it, we will try to implement later. Okay. Uh, so first step, what we have to do here? So we have to see there is seasonality is there or not, and we have to remove from it. Is it the first step or any other thing it is there?
No, first we have to remove the seasonality only.
Seasonality
I
only.
think it is.
So how we will find
Yeah.
out the seasonality?
Yeah, what
Or
period of time
did
it is
we
repeating, that's what we have to find out to remove the seasonality, I think.
Correct. So since we are taking hourly data, okay, whether
Yeah.
we will keep with hourly data or
Yeah,
because
if we are taking for hourly data, then we will keep up with hourly data
okay,
only.
then in hourly data clearly we can see there is a seasonality, right?
Yes.
Now how we will remove that? We have seasonal data, whether with the thing which I have told, like original data minus seasonal data only is a thing, or is there any other thing?
no like do we have an option of applying time series modeling on non-stationary data?
No. It will the accuracy metrics will have lots of error, lots of, and the forecast and the means what we predict and the actual value will vary a lot.
Did we try that?
Yeah, and the AIC value will also vary very much.
Okay.
I've tried that in that way, so I'm saying
But
I've
we have
tried in that.
seasonality data, na Sripati. Why we have to work in that direction? Because clearly the graphs are saying seasonality.
See, the AIC value is too much high in 1 lakh. Try to predict it for. I tried to predict it also. See,
Which model you
Okay.
tried?
So
I tried a Rima model.
if you double click, it will get zoom.
Yeah, yeah, it's
Oh, I
zoomed
haven't
only.
tried.
It's giving prediction also, and the main for checking the accuracy of the model, main is map. This mean absolute percentage error, and it's giving too much of value.
That
Zero.
is what that
One
is
point.
still later stage. Okay. We are
Yeah, means I have tried
still
it to
okay. Good.
confirm whether it is
Mm.
predicting or not. Seasonality is where we are
So that is what.
stuck
So
up.
we will walk okay 1 or 2 steps at least. those two steps will conclude and we will just close all. So how we will remove seasonality? My code will say like you take the original data and minus the seasonal period, then you will get removed. Is the statement correct? If it is not correct, what is the other approach?
Would you repeat one more time?
So I have shown the code, right? Whatever
Yes,
seasonal
yes.
period it is there, that data set we have, okay? And actual data set in
Okay.
the top it is there. So if you minus these two, then the seasonal data will get removed. That is what in one block I have read and I have shown to you guys. So is that
Yes. This.
statement correct, or is there any other thing it is there?
No, I think it's correct because seasonality can be measured from that only, removed from that only.
But
And and from the difference also we are trying to do that only.
no, no, we are not doing that one from the difference
Means we
because
are taking the previous value and we are differencing with the actual value
correct,
from the current
we
value.
are making difference wise it is correct, we are subtracting. But what
Yeah.
is seasonality between second and the current one? There is no seasonality, we are guessing, we are directly minusing there. What my observation says na, see if it is a additive, the example which the 246 I told na, that it is matching because the relation between the thing is if it is additive or multiply to, then if you minus na, that one, then the values output, whatever the output of it, it will make a straight line.
Okay.
So
So
that
we are stuck at the point of how to remove the seasonality, right?
correct.
Yeah, this graph should be straight.
This we have to make somehow that graph should be straight, okay? So how we have to make it straight? Because seasonality we have to remove it all totally.
Yeah.
And in the later case example which I have told, there we are not removing seasonality, we are removing the relationship between the t and t plus 1. Even the difference also do the same thing, it will try to remove the relation between the two things, but it is not the relation is not the seasonality there.
Yeah, yeah. Getting the point.
So okay, so any other apart from difference, how we'll make by seeing go out of this box, okay? See the graph, okay? By seeing the graph, how we can make it uh, compress or smoothen. And smoothening I have heard so many times, what we can do with the
Yeah,
smoothening, it is
it's
only rolling average, right?
a rolling average. Yeah, it's doing rolling statistics
So,
only. That's what
that
it.
also I have seen. So what they have done, instead of so many hikes, original data minus that weighted average. That I have seen so many blogs. It is giving some good output. Like original data minus give weightage to the latest one and less weightage to the past one. Okay, so that the weighted sum it will have more impact, so that the recent one will have more relation, those weight it will keep, and old one it will give less weightage, so output prediction will get come closer, so that auto correlation between the things it will improve. Indirectly there are stationality will come. So original data minus weighted, whether we go that one. Have tried, you tried right that one also?
No, I have not tried. I have seen somewhere. Yeah, it's
EVM,
weightage rolling
EWM,
mean.
yes correct, this one EWM.
Yeah.
Try to do this one, means after first difference second difference na, everyone is suggesting this is the best because it is giving weights.
We are m- moving average from the original data, subtracting the moving average from the original data.
Yeah, that is what rolling average is one thing. Even that it is not working, they are going with weighted average, weighted mean.
not tried for this. I will try it.
No, we'll try. No, it's simple code only. It's not complicated.
Yes. Okay. What we have to do?
Same take that. Keep this. If you want to copy the total code in the new row so that we can compare the graphs again and again. Or take screenshot of this graph, whatever that 4 trend, and for comparison, we will take even screenshot. That will be okay. So original data minus the
Okay.
weighted average data, we will do it, and after that again we will check the seasonality.
Okay. Here only we do, or since
That is what.
in the new
So for
file.
me, if you take the screenshot and keep for reference, that will be okay. Or else if you copy and paste somewhere in the bottom, that will be also okay.
Okay,
this
I'm
is this
taking
is
the
what
screenshot.
Sripati, which I have expected. I have seen also what one guy did na. He written everything in as a function, okay, and if you change that function and whatever the final output data set, right, if you are giving that data set to that function, it will generate these two graphs. So one is linear, how many graphs you will define inside it, it will automatically generate that one, so that copy pasting job of multiple things, it will like it will avoid.
Yeah, it's like one function fulfilling multiple
Yeah,
purpose.
Multiple graphs.
calling the function multiple times.
Mm. So we have only two graphs, so we can, for time being, we can rerun, that is also okay.
Yeah, we can rerun it. So
So make some
what
new
I have
cell,
to do?
make some new cell, okay, create a new data
Oh,
frame, which is actual data frame minus weighted some data frame. Just keep no need to give data
actually,
frame na. df is equal to
oh,
df is
simply,
equal to that
yeah,
whatever data AQI minus minus that weighted average formula is there, right, you keep paste it there.
I actually
So
it's not there here. So
here na, so data dot ewm, ours is data, right,
data.ewm. Okay,
ours is data frame
yeah,
is data, but inside any parameter is there or not, it
data
try to check it. What is ewm, whether we have to give any parameter inside it.
mean mean variance, standard deviation, correlation, and covariance are there.
So which one we will give?
So then go for we can take for mean.
Okay, let's try with me. We'll see how data is like calculating, it is having any impact or not.
And what is this com 0.5 dot mean? It's taking,
No, no,
it's defining some.
that they're like doing as an example, right?
So what we do, we for the AQI data we have to
Uh,
calculate it, na?
try
For the
to
AQI data we are
create a new cell, keep like that same thing, keep a new cell and keep only data.ewm, and inside it whatever you want to try it and see whether the data frame is coming or not. After that
okay.
we will subtract it. Just give empty any error, or by default it may
Zero
take.
dot mean I calculate.
Wha- why dot mean? Dot mean is single value, it will come, right?
Yeah.
Run it, we'll see.
Simply I execute this only.
Execute. Let's see whether any error it will come. Because I am expecting it will give data set.
It will must pass one of the
So
commas or
keep it
pan.
mean inside. In the bracket, keep it that
Okay.
as per syntax mean is there, na? Like that.
Again, it is not defined.
No, go
Uh,
go to the function help, that how they have defined, we have to define the same way. Try to keep mouse over, not EWM, you keep the mouse cursor. Don't go to the example.
0.5.
Don't go to the example there. Wait. So variable what?
Alpha
Go syntax.
parameters
Parameters. It
and
is
degree in terms of it is
come. Okay, leave it.
wo-
Come down. Come down. Where mean they have defined.
they have defined
In the first line itself, it is there, right? The first line. Go top. Go top. Still go top. Go top.
yeah
Here.
me
So provide exponential weightage. Okay. Functions, variable functions, and half-life. Even he has given Shubham 12. I don't know what that half-life means. But
exponential. I have not read
so
about that.
inside we are not giving anywhere.
Com span exactly one parameter is asking for within this. Com span, half life or alpha. What are this? Com float optional.
Hey,
Specify decay in
Aman, we
terms
can
of
try the same, no? Com equal to 0.5 and then mean
yeah.
what
Well,
the sample it is showing up.
What is half-life?
half life. Oh, we can
Because he tried, that's why I got the same thing. What is it
time
saying?
delta. Specify in terms of half life.
That will be good, right? So time delta, how much 1 hour we have to give, means it is like lag. How much lag we have to
Yeah.
make it? That will be more
Only
clarified.
observation decay to half its value.
This meeting is also getting wrapped in 5 minutes.
Yeah, it is okay. We can rejoin. It will be. So at least whether we have to keep that dot mean in the end, that is what my doubt.
Yeah. We have to keep it at end only.
Remove and try.
No, that is how it is going, na?
No, remove and try. I want to see at least one time. Because EVM itself, if it is a function, then why we have to keep. Okay, it is
Zero
like
point 0.5 minimum
it
period
is
time
like a
exit.
rolling window. It is making over that whatever thing we want, we can make it mean or variance like that. Okay.
What is this com and half life? We have to first understand this only.
Uh,
What's it is.
that we
Then
will go
we'll
deeper
find
individually. That's not a problem. At least we'll see if
yes,
weighted
yes.
average is going fine or not. So
One point is this to go exponential moving window.
uh,
Yeah, we can keep it 1 point.
and this is like advanced dot mean, you keep it now, and in the above code directly copy paste this one, and minus it and try to reshape all that visualization. Even that is what we are subtracting rolling average mean, but what was happening if you are applying visualizing stationarity we are doing, but how it is subtracting, that is what I am not getting.
Line plot. We try to draw line plot.
Uh, This DF you give, no? DF directly give DF there.
Yeah, yeah, we can compare it with.
Ravi, maybe you can like give your views here. Here, you have to work on this because we have stuck up. So we also need some other alternative approaches. At least one of anybody approach may work out. So time series data we can
Yeah,
give somewhat later also.
speed is not defined.
To run from top.
Just import first code. And before
Restart and run all, yeah.
no first line it is there. Okay. It's okay. So Sri, you got the thing right where we really struck it up.
No, no, yeah, totally. I got it. It is how to work on non-stationary data. What are the things
No,
to be
that
done to
statement
make
still I
it?
didn't agree Sri, because I can see
Uh,
stationarity because we seasonality if you remove then we can get
uh,
stationarity. Oh, so we don't
okay.
have
So you mean to say how to remove seasonality? That is what.
that correct.
Okay.
Actually, it's
Okay.
crashing. I don't know why, but it's not
For plotting.
taking the. Yeah, in plotting, it's crashing. RAM, it's using all RAM.
Then there is some bug in your code. Yes, you have to remove null values, right? If it is there, is something like that. Drop an a something. Again, you have to import. Try to import pandas here itself. In this line. Really good.
Oh, data also.
Even when I see this error, right, I feel proud of we are making collab full busy and we are crashing.
Google will complain or they will ask that what research you guys are doing, trying to learn something. Today I was thinking like that only when I was running Collab. No, at one point while visualizing, it got stuck for 10 minutes. I
Yeah,
thought like
meeting is
something
going to
is
close.
going.
I will reshare at least at this point now. We'll get some view and then we'll close if it is getting delayed for everyone.
So I got the point. We got stuck where others are joining. You sure?
Yeah, money is joining.
Okay.
I will make him host.
So that is where it's been said. No, data science project more work is on data cleaning.
Yeah, and the thing
So
is, we are
still we are in the data cleaning phase.
Yeah.
pre-processing. I can say cleaning. We have done enough of thing. Yeah, really. When I remember those days,
No, no.
data cleaning. Oh
This
my god.
cleaning is not only like dropping the null value or filling.
Oh,
It's
we
like
have given different
it,
name now. Pre-processing. Why we call it the same name?
pre-processing. That is what. So now the new terminology will be data readiness. We
Uh,
have to make data ready. Then we will think like, okay, prerequisites we have met, and then we will say, yeah, now model selection will do. No,
so
but
and
again, I'm challenging here data. I'm here challenging the way we are getting data from the site and how the application they are revealing the data. That is what,
that maybe let
because
it be inaccurate. See, what is the problem with this? Our thing is not
no,
building.
that is where no. If it is a completely messed up data and we are trying to bring out something top of it, then yeah, the try we are giving is good.
Uh,
But assuming the result is going to be accurate is not
that
going to
that is the
work out.
thing. If we take some Kaggle thing, then by this time we might have done deployment also.
Kaggle,
Since
they have already made the things available. What they will do, they will remove all the null value.
correct, not only null, whatever outliers, everything they will keep aside
They
and
will
keep it ready.
they will clean it. Yeah, they will
Uh,
have a tool. It will clean everything, and then it will be a very like straightforward data, and people will play on that.
correct. So now learning will be more in this process
Correct,
when
correct. I totally agree. But I'm telling no, the phase we are in. Actually, we thought of completing model by this weekend, but we are still in the pre-processing phase.
so if that is then what else it is there? Only run multiple models over it and get the score.
Correct.
Yeah, if once it becomes stationary, then there is no big deal to build model.
Okay,
Hmm.
no need to run like for getting that output. Okay, means for reaching that target. Uh, we will learn the things. Okay, when we feel like okay we have done with satisfaction, then only we'll move to the next step. Or else moving
Yeah,
like
yeah.
is useless. So,
Okay, okay.
Aman, is it like working out? The graph is coming or still it is
Yeah,
frozen?
yeah.
No, no, it's crashing.
So, Iswar, what we will do, let's keep the meeting here only.
Okay.
We got the point. The takeaway for today is like we have reached to a situation we have to remove the seasonality from the data and then try the stuff, right?
And Aman, can you do one thing? So the idea of mine, you got it right. So whatever data, na, I will give only one data set. It has to give those two graphs at present. Maybe in future we will add one more graph. Okay, keep these things in one function, define it in the first. Okay, and whatever transformations we want to apply, we will apply. Finally, we will give one name to that final transformed data set and we'll call with that function so that we can directly visualize okay the stationarity linearity correlation wise whatever it is there is not we have to see those three graphs with that function. Can you make that one at least so that it will be
Yeah, I can
easy
try.
for them, huh? You
Yeah.
can try, right? So it will be
Okay.
easy because you feel that difficulty, right? We have to copy paste so many things and run the cell. Okay, that things we can skip at least if you make that process easy there, right? We'll try to change values so many times and just call that function and readily graph will be available. Then we'll feel like this is not working, okay, change that value to another thing and rerun. That will be like it will be like handy.
So
Not
you
take
mean to say
much
a
time.
function will be defined for plotting
Correct.
uh, in for any data, right?
So
For any data set.
I will give one data frame, okay, one series data.
Hmm.
If I give
Hmm.
that series data to that function, it has to give
Hmm.
that graph, which two graphs we have seen, right? One
Hmm.
decomposition graph, one is that linear graph. In future, if you
Hmm.
feel like for to analyze more graph is needed, then we will define only in that function but every time of
Correct.
for transformation we may run 100 lines, okay, but after that we
Hmm.
will be having only one value that is the one variable that is data frame, okay, that we will call in the
Hmm.
function. So we'll see, okay,
Hmm.
this is the output. because or else what
Got it.
he is doing, he is rewriting, copy pasting
Copy
all that
pasting, copy
code, and
pasting.
he
Yeah,
is
yeah.
renaming that every time.
Because
That is like killing most of the time, sometimes crashing.
fine.
Okay.
Okay, okay. Then tomorrow we have meet with them. So Sripati, anyhow, he will take care of tomorrow's, because it's
I will listen again. You please carry on.
no,
I
no,
don't know
no.
where we
And
are
see,
now.
last meeting, what happened? That
Uh,
Shivani and then Reena, they come up with
hmm,
one word. Okay, sorry guys, we haven't worked. We didn't get time to work on it, and
hmm.
maybe by Tuesday we will try to come up with something like that. Let it all close. Tomorrow you can say something. I am not feeling well. Okay, I didn't concentrate much, and you can, but you can ask, you say that word, and they keep on asking
Hmm.
the things like that same thing, na. You they will try to, definitely they will try to present something, because they told one, they skipped one. So tomorrow at least something they try to. So you say, utilize that word tomorrow and try to school them. It's good. Tomorrow is your.
Okay, we'll see to it.
One guy was working,
Shubham, and one more thing,
Shubham.
Shubham, he's very good, and he
Hmm,
has done previously also on time series, and whatever Raman has done, like
hmm.
that, he has come up with the full data, means worked on
Okay.
full thing, and he also discussed. Involved into the project much, and he also wants to discuss much. He's not the status kind of way, asking status kind of way. He's asking us
Hmm.
suggestions, and he's ready to implement those suggestions and check whether it will have some better improvement or not.
Okay.
So we can pull that guy like that. Even we have indirectly told him. So don't.
What about Jani Basa when he is back, coming back?
I don't know. Maybe till first we cannot expect. Okay, so let this
Hmm.
year finish. Then
Hmm.
in Jan we will try to meet that guy, or as a team, because this is going in full phase, right? So let it go another week at least, so that we will come
Hmm.
out of it easily,
Hmm.
because it is in the hot cake stage, hot seat. We are in hot seat with this project, okay. So once we have some confidence in it, na, then
Hmm.
we can easily come out of it, and we can concentrate on that one.
Okay.
uh, Anyhow, the other guys also not been that much active now, so let it go.
Hmm.
So once we are confident in this, then we will make them also, like by pulling them for more meetings and discussions, we'll make them active when we are ready.
Sure.
Okay. Okay, then
Yeah.
I think, okay. See you tomorrow. But Aman, when you complete that one, try to post in the WhatsApp group, whatever it is.
Okay.
No need to IP and way. You can upload that in Git and share that link also. That will be also good. Okay, that will be also fine.
Okay.
So that I will also try to, like play with those variables and see how the stationality is getting removed. By doing what it is removing, we are not clear yet, but at least by trial and error we try to remove which one is doing the best thing, and reverse engineering we will do over that, why this is removing, why not other.
Okay. Okay.
Okay, then okay, Sripati, see you tomorrow then.
Yeah. Thanks.
Thanks,
Thanks.
Bye.
Aman.
Thanks, Raman. Bye bye.
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 Good night.
Good night.
Good night.